Okay, section 3.2, solving inequalities using addition and subtraction. Your vocabulary and definitions. First one is, oops, my bad. Put down the pen, and then move the box. Inequalities that have the same solutions. Okay, addition, subtraction property of inequality. Adding or subtracting each side of an inequality by the same non-zero number. Basically, you solve inequalities the same way you solve equations. You have the addition subtraction property of inequality. Adding or subtracting each side of an inequality by the same non-zero produces an equivalent inequality. So, oops. So, for example, if I want to solve this one, if it was an equal sign, what would I do? I would subtract 4 from each side. So I subtract 4 from each side. Just because it's an inequality doesn't mean that I don't solve it the same way. Okay. So first example. What are the solutions to inequality? Graph it, so I need to solve the equation. To do this, I have x minus 15 is greater than negative 12. So I add 15 to both sides. So I get x is greater than negative 12 plus 15 is 3. So I have an open circle on 3, and I want everything bigger because x is greater than 3. When you are graphing, if it is a less than or greater than, you have an open circle. If it's less than or equal to, greater than or equal to, you have a filled-in circle. If it has the extra line underneath, you have the extra ink in the circle because it can be that number. X can't be 3, but it can be everything larger than 3. Okay, problem number 2, solve an inequality, checking the solutions. Problem number 2 is your turn. You do that. Pause. Okay, let's go ahead and solve this one out. So I want to add 3 to both sides, and I get 13 is greater than or equal to x because it's greater than or equal to. Now notice there are no numbers on the number line. There's one number I'm concerned with. That number is 13. Write down 13 on any of the spots. I have a closed dot because it's or equal to. And then you have to ask yourself, are all my numbers, is x smaller than 13 or larger than 13? 13 is bigger than x, so x has to be smaller than 13. So I want all the numbers going this way. Problem number 3, your turn. You try that one too. Okay, so we're going to solve this problem. I have x plus 6, so I subtract 6 from both sides. And I get x is less than negative 4 minus 6 is negative 10. Or I should say x is greater than that. Once again, there are no numbers on my number line. So what's the only number I'm concerned with is negative 10. Because x is greater than, it's not or equal to. There's no or equal to. It's an open circle. And x is bigger than that, so I want everything larger than that. Problem number 4, writing an inequality from a graph. A hard drive on your computer has a capacity of 120 gigs. You have used 85 gigabytes. You want to save some videos to your hard drive. What are the possible sizes of the video collection you can save? So we're going to use V for video. And I don't want to write an equation. My total capacity is 120 gigs. That's my total capacity. I cannot be any larger than that. So I have what I want to put on, the videos I want to put on, plus the 85 gigs I have already used must be less than or equal to 120. It cannot be larger. It can be exactly 120, but cannot be larger. There's my inequality. Now, to go ahead and solve it out, subtract 85 from both sides, and I get the number of videos must be less than, or I should say the memory for the videos, size of the videos must be less than or equal to 35 gigs. Okay. And that's all, folks.